citation reads as follows. Be it known that for his exceptional achievement in the discovery of the planet Pluto, ninth major planet in the solar system, for his lifelong devotion to astronomy through research and teaching, and for his instilling zestful and enthusiastic appreciation of science in his colleagues, his students, and the public, the Board of Regents hereby awards the Regents Medal to Clyde William Tombaugh in ceremonies at Las Cruces, New Mexico, February 18, 1980. Ladies and gentlemen, Dr. Tombaugh.
Thank you very much, Mr. Humphreys and the Board of Regents for this great honor you have bestowed upon me. I am deeply indebted to you.
A banquet at New Mexico State University in Las Cruces. Its purpose? To honor the only living man who has discovered a new planet, Clyde Tombaugh, now one of America's senior and most respected astronomers.
Also, I want to thank those who, there were so many came, the response was overwhelming. I had no idea that two little tiny black specks on some glass plates would cause this much of a rumpus.
Here at the University of New Mexico at Las Cruces, it's a very special occasion. 50 years ago, Clyde Tombaugh, who you've just seen, discovered the planet Pluto. When he made that discovery, he was a young, unknown amateur who hadn't even taken his degree. Nonetheless, he'd been handed the task of locating a new world, and within 2 years he'd succeeded, to the amazement and delight of the whole scientific community. Now, 50 years later, his colleagues have gathered to honor him. I first heard of the discovery of Pluto when I was a boy, and I little thought that a long time after I'd be sitting here talking to the discoverer. It must be a great moment for you, Clyde, and I'm sure you had no idea that it would lead to this when you first went to Lowell Observatory way back in 1929.
No, I sure didn't. It's very different from what I expected.
How did you get to go to Flagstaff in the first place?
Well, I had just completed an excellent 9-inch reflector telescope, and I had made drawings of Mars and Jupiter's eyepiece very carefully. And of course, it showed a lot of detail, and I sent those to Flagstaff, and apparently the detail impressed them because, of course, they could check the accuracy with their current photographs.
And of course,
so after a few letters exchanged, the director, V.M. Slifer, invited me to come out to Flagstaff on a 3-month trial because they said that they were getting a new photographic telescope and needed someone to operate it. Now, of course, I wanted to work in an observatory. I wanted to get into astronomical work. And since I did not have a university training degree at the time, why, this was a very unusual opportunity. They were the only planetary observatory in the United States at that time, I believe. Well, I was keenly interested in planets, so it turned out that after I sent these drawings in, that he offered this. And of course, that was an opportunity of a lifetime.
But you had no idea you were going to be set to hunt for a new planet?
Not until after I arrived there. Well, V.M. Slifer came down to the Santa Fe depot to take me up to the observatory. And I often wondered how impressed him, a green country farm boy from the plains of Kansas. And so 13 months later, here I found a planet. That was, of course, a much quicker surprise of turn events than we ever dreamed of.
What sparked off your first interest in astronomy when you were a boy?
Well, I had a very keen interest in geography. I had a kind of a photographic mind. I could see maps and boundary countries, everything very avidly. And then one day in grade school, the thought occurred to me, I wonder what the geography would be like on other planets. Then I got interested in astronomy, started studying astronomy. I had an uncle who was an amateur astronomer, lived about 9 miles from us, and he had my first view was at his own 3-inch single lens refractor with all the colors, you know, and that was the first time I had views of Saturn's ring and Jupiter and the satellites and the craters on the moon.
What about the original making of your first reflectors? Was that really a problem?
Yes, there was no one around to help me, and the first one I made, there were no adequate directions. And of course I made some and said, oh, it worked after fashion, but it wasn't a good one. And then the following year, the Scientific American came off the first edition of amateur telescope making.
Yes.
Well, then I could see where I had done some things wrong, and I learned some of the detailed tricks. So then I made a 7-inch for my uncle. It turned out pretty well. Then he gave me a check, and the money I had from that, over the cost of materials, I bought the materials for my 9-inch. So the following year I made my 9-inch.
That's the one you have now?
Yeah, and that's where the whole tide changed.
I must say, it's a magnificent telescope, and it works beautifully. And I do love the idea of the way you're uncovering and capping parts of it with tin cans. Had you got very much experience in actual observing by the time you went to Flagstaff?
Quite a little. I had a small telescope, of course. I observed the Saturn's edge-on rings in 1921 with a 2¼ inch from Sears Roebuck catalog. And of course, then I wanted to get more powerful telescopes, and we were in hard times, and so the only way I was going to get it was to make my own telescopes.
Which you certainly did. Had you ever had any idea about a possible planet beyond Neptune? Was that entirely new to you?
No, well, I had never even thought about that. I figured Neptune was it.
What strikes me as being really amusing is that having discovered a new planet, you then went to university as a freshman to take your degree. I wonder what people there thought about that.
Well, they were very nice. They granted me a 4-year scholarship in science. And as I said, the professor at Dinsmore Alder wouldn't let me take the beginning course, 5-hour course in astronomy. He said it'd be ridiculous. So not until a little later, I took a more advanced course in astronomy.
Well, you've certainly come a long way since then, but of course it all does go back basically to that discovery of Pluto way back in 1930.
Yes.
We're going back half a century, of course, and when Clyde arrived at Flagstaff, there had already been previous unsuccessful searches for a new planet, and at a very early stage, the Lowell Observatory had been involved. The observatory was founded in 1895 by Percival Lowell, a diplomat-turned-astronomer, and he became fascinated by the problem of the red planet Mars. And he built the Lowell Observatory at Flagstaff, mainly to observe the planet, and there he installed a very fine 24-inch refractor in a dome shaped rather like a wedding cake. Well, it's a very good telescope indeed, and I know that because I've often used it myself. Now, Lowell believed that on Mars he could see strange linear features, which he called canals, and which he believed to be artificial. Well, we now know, of course, that he was wrong about that because the Martian canals don't exist. But Lowell was also a very skilled mathematician, and he became interested in the movements of the outer planets, Uranus and Neptune. They were the outermost planets then known. Way back in 1781, Uranus had been discovered, fortuitously, by William Herschel. And as time went by, astronomers realized that something was wrong. Uranus wasn't behaving as it should. It was straying away from its predicted path. Something was pulling on it, and that something could only be a planet. Two mathematicians, Leverrier in France and Adams in England, made calculations, quite independently as a matter of fact, to find out where the stranger might be. And when the observers pointed their telescopes in that position, there it was, and that was the planet Neptune, identified in 1846. But later on, Lowell looked at it again, and he still wasn't satisfied. There was something not quite right, still. And therefore, he made new calculations and worked out a position where yet another unknown planet might be. And then he started looking for it, using the equipment at Flagstaff. But he didn't find it. He searched and searched, and when he died in 1916, the planet was still unfound. And there, for a long time, the matter more or less rested. The hunt was given up. But then, in 1929, it was taken up again because the observatory acquired a new telescope specially for the purpose. And this was a 13-inch refractor. And the man put in charge of the search was no less a person than Clyde Tombaugh, who went to Flagstaff specially for that purpose. So the telescope was then at Flagstaff. It's now being moved to a new site at Anderson Mesa, which is about 12 miles away. A few days ago, I went there and found the telescope looking just as it had done in 1929-1930. I think it's natural that this telescope shall always be known as the Pluto telescope. It's set up on what we call an English mounting. That's to say, the telescope itself is mounted upon a skeleton axis which is slung between two massive piers. It may look a bit clumsy, but it's very steady and it's very effective. The telescope itself may seem surprisingly short for a telescope of this aperture, and that, of course, was intentional, because it was designed to photograph wide areas of the sky with a single exposure, and having a short focus telescope is the best way to do it. Note also the very massive guide telescope. That is a 7-inch refractor, so that's quite a major telescope in its own right. And it had to be there because every plate had to be so accurately guided. What Clyde was doing was to take 2 photographs of the same area of the sky, separated by a night or two, and then compare them. So every star had to be pinpoint sharp. The slightest blurring would have made the plates useless. Obviously, this telescope has got a very good mechanical drive, which didn't give very much trouble. And that did most of the work. But you've got to expose for at least an hour, and sometimes Clyde went up to as long as an hour and a half. And you can't trust mechanics that far. So, very regularly, he had to check in the eyepiece of the guide telescope to make quite sure that the guide star wasn't wandering out of the field. Below, we have a small finder that gives a very much wider field. And on the top of the telescope, you can see 2 more cameras. Well, one of them is a 5-inch, and Clyde very often did use that to take check plates. The other one's been added since and has no connection with the Pluto story. All in all, this telescope was designed specially for this one particular purpose, and so was the lens, which is a Cook triplet manufactured by a very famous optical worker named Lundin. When it was made, it was probably just about the best of its kind in the world, and I suspect that it still is. It is well nigh perfect. So it was with this telescope that Clyde used for his triumphant hunt for Pluto. But taking the plates is one thing, examining them is quite another. Remember, each one shows thousands of stars. And if you try to take sheer manual checks, it's a hopeless business. Other people had found that. So what was the answer? The answer lay in a special device known as a blink comparator. And one was acquired, again, specially for the planet hunt. It's still down in Lowell Observatory, and I asked Clyde to show us exactly what it was and how it worked. So we hadn't heard Clyde from down here.
Okay, thank you. Be nice to get in the warm room here.
Back in the familiar room again?
Yes.
Right, I know that this is the blink comparator you used when you actually found Pluto, but not everyone's going to know what a blink comparator is or how it works. So, will you explain it to us, please?
Yes. You have 2 plates on the carrier, and you compare one against the other with a shutter in here that shows you this view and this view in rapid succession. Now, you have to make very careful adjustments to get the stars to superimpose. So when I put a pair of plates on the machine, we'd sweep half the width, and I'd have to make adjustments, horizontal adjustments here, vertical adjustments here, in and out with this one, and then these are the carriages where I do horizontal strips. And when I finished a strip, then I'd move it up the next strip and go again until it covered a section.
What was the actual procedure? You were looking through the eyepiece?
Yeah, but every time that I would do a new, go to a new section, the whole thing had to be very carefully readjusted. You had all these variables, and it was quite a trick. And finally, I mastered it fairly well. And then in the blinking, this is the thing that turns on for the automatic clicking. And if I wanted to look at something more carefully, I would shut it off and use this hand blinker here and look in like this, you see, and study the thing as to what to do about it. That's the way I did it.
What you do is to look at the 2 star plates, one after the other. The stars are in the same positions on each plate because they don't move relative to each other. But Pluto does. And you can see it here, between the 2 identification lines, as a winking spot.
And, of course, the thing I was looking for, the plates are taken at opposition, the region opposite the sun in the sky. And at that stage, and everything exterior to this orbit is in retrograde motion, apparent retrograde to the west. And so by using the Earth's daily orbital motion, I had a means of a parallax effect. The asteroids, of course, being closer, they shifted much more, and the more distant planet less and less and less. So when I ran into a planet suspect, immediately I knew its approximate distance by the parallactic shift.
These are the actual Pluto plates, aren't
Yes, yes.
How did you know that that particular spot of light was Pluto?
Well, of course, it was one of the best suspects I'd run into in many months, and I felt the time I saw it that was it. The shift looked perfectly to fit an object considerably beyond the orbit of Neptune. Actually, the original shift here on the plates was about 1/8 of an inch. And however, you can have a couple alternating variable stars that could fool you, as well as defects. So then I removed one plate and put another plate on, taken a different date, and to see if the image was confirmed on it, to see if the change in position was consistent with the apparent motion indicated by the discovery pair. And then I was 100% sure.
What were your initial reactions, Clyde?
Oh, it was a tremendous thrill. I looked in there and I spied it almost immediately, and a tremendous thrill came over me, and I almost shook. And I realized I had some big game. And so then the thing was to study it and make further checks. Then I went down and notified the other members of the staff.
What did they think about it?
Well, they were electrified.
I'm sure they were.
They came down quickly to the room, and I showed them the setup and the dates of the plates and so on, and that it conformed to that of a trans-Neptunian body.
Pluto, of course, turned out to be much smaller and fainter than anyone had expected. Was that why Lowell missed it?
That was part of the reason, yes. Because of that difficulty and other features, more stars, the technique had to be considerably refined, which I studied and worked out over a period of many weeks. And I wanted to make I knew it would be a lot of effort. So I studied it carefully, and so as to make a very surefire search, so that if we didn't find anything more, it would have significant meaning.
When you discovered Pluto, and you'd had this tremendous success, and taken your degree, but you then went on searching for another 13 or 14 years.
Yes, about 13 years more.
Why was that? You thought there might be something else there?
Yes, well, there were two reasons. One was that there was some, they wondered whether what I had found was the real planet X, that the real planet X was yet to be found, possibly. And the other was the other astronomers saw that Pluto was rather an unusual object, and many wrote in making a plea that the search be continued, because they said, you have the instrument and the expertise, what else is out there? So it seemed most appropriate to make a wide sweep over the heavens to see if anything else could be picked up within the range of the instrument.
How many stars did you examine altogether?
Counting the images on both plates, 90 million star images.
Well, you've made a very thorough search, both sides of the ecliptic, and what do you think is the limiting magnitude now? I think somebody once said that what you found was important, and what you didn't find was just as important.
Yes, Kuiper suggested that, and I would agree with that. I would guarantee the search down to the 16th and 1/2 magnitude, but objects as faint as 17th had a very good chance of being found. And of course, you have a lot of defects and false images, and they will appear to constitute a planet suspect. So every one of them I checked with the additional plate, and that was the final answer, and I must have checked over 10,000 of those objects.
Now that we know so much more about Pluto, do you think it really is the planet for which Lowell was hunting?
Well, in view of what we know now, it appears not. The mass is much too small. Of course, Lowell realized that the residuals he was using were marginal, but it was the best he had. And of course, when you search to such faint magnitudes, you want to try to get some idea what part of the sky it is in because of the work involved. And so it turns out by accident, apparently, that Pluto was within 6 degrees of its predicted position. And another amazing thing is that many of the elements he predicted also were borne out by the actual orbit. And though this had people thoroughly confused, astronomers were in great controversy as to whether it was meaningful or not. And this debate raged for years after the discovery.
Did you think there might be something else out there?
Well, there may be smaller ones further out. Within the limit of my survey, I could have picked up a planet like Neptune at a distance of 7 times Neptune's distance from the sun. So this removes all doubt that there are any more of the giant planets according to the Bode's law of spacing.
If you'd realized how great this task was going to be when you first came to Flagstaff, would you have still taken it on? I think you would.
Well, I might have, when I was told by Dr. Schleifer to start blinking the plates, they had the impression I would take the plates to the telescope and someone else more experienced would do the blinking. And the blinking just didn't get done. And so one day he came down and said, I want you to do the blinking. Well, I shuddered at the thought because I had been examining the place after the processing, home up in the darkroom, and see if the images were all right. And I had a fearful concept of what I was confronting. And I wasn't overly enthused about it at the time.
So there was Pluto, quite unmistakable, but it was very much smaller and fainter than anyone had expected. And even now, we are not quite sure what Pluto really is. Is it a proper planet? Is it a minor planet? Or could it even be a dead comet? We don't really know. And the situation's been further complicated by a very interesting discovery made quite recently, in 1977, by Dr. James Christie and his colleagues. They were looking very long and hard at photographs of Pluto when they realized that the image appeared to be elongated. And this could be due to the presence of a satellite. And it's even been given a provisional name, Charon. Now, if Charon really is there, and if it is a satellite of Pluto, it's an exceptional one, because it has about 1/3 the diameter of Pluto itself. And therefore, there would be grounds for supposing Pluto and Charon to make up a double planet. But at the moment, the whole situation is very much in a state of flux. No one's succeeded in obtaining photographs of Pluto and Charon separately, so we can't be quite sure that Charon is there. But it does make Pluto even more extraordinary than we first believed. And even though we've known it now for 50 years, there is still a great deal about Pluto that we don't know. 50 years is a long time. Now, Clyde Tombaugh is Professor Emeritus at the University of New Mexico. And he's a very active one, as I was told by Dr. Herbert Beebe, the head of the Department of Astronomy.
Yes, he is, Patrick. He comes in every day and works at his office, and recently he's been working on a book, but he's also grinds mirrors, still a very good telescope maker.
So, in fact, in his case, retirement means very little.
Sure. No, nothing at all. He retired in 1973, and I don't think he changed his pace, although I think he's more comfortable now that he can spend more time with the graduate students on an individual basis, and also the other faculty members. I think we all owe him a lot. I think his enthusiasm, his attitude, his enjoyment of astronomy just, well, wears off on all of us.
We've known Pluto now for 50 years. It's very much a world of mystery. There's still a great deal that we haven't found out about it, but we do know it's important and it's significant. And the story did begin with Clyde Tombaugh, the man we've come here to honor. At the banquet, there was another special presentation, an asteroid or minor planet. Asteroid 1604, photographed by Clyde Tombaugh during his search so long ago, has now been named after him. And Clyde, characteristically, had the last word.
Thank you very much, Henry, and Dr. Hoag and the others of the Low Observatory, the Low Observatory for handing me a nice little planet known as an asteroid. Now I feel that this is a great honor, and I thank them very much for it. This is a beautiful plaque I have here, and I thank the Low Observatory for giving me an asteroid. Thank you. Because now I have some real estate that nobody can touch.